Okay, so we're going to do long division again. We've already done that once before with no remainder. Now we're going to do ones with a remainder. All right, so Unit 2, Day 6. Quick review. If you were going to divide these two, whether you use the box or long division, I'll do the long division the first time, okay? So x squared plus 3x plus 2. So x goes into x squared, x times x, x squared. X times this is positive 2x, sorry, x times 2 is 2x. So change each sign, this cancels, this becomes 3x minus 2x is x. Bring down the plus 2, x goes into x, a positive 1 time. 1 times anything is itself. Change each to subtraction, these cancel, and so does this. That's a remainder, 0. So this whole thing just equals x plus 1, okay, since there was no remainder. And the other day I showed you that if x plus 2 does give us a remainder of 0, then negative 2 is a root, right, the opposite of the factor, and negative 1 is a root, since that's also a factor. Okay, that's all old stuff. Now we're going to do ones with a remainder. So notice you have this, and this is very similar. It just has 3 more in the numerator. So if I go to do division again, x plus 2 divided into x squared plus 3x plus 5 this time. This goes in x times that is x squared, x times that is 2x. Same thing, change each sign, this cancels, this gives us x, bring down the plus 5. X goes into x plus 1 time. This gives us x plus 2, because 1 times anything is itself. Change each sign, this cancels, this doesn't now. This is the only difference from what you have already been tested on. Everything else has been stuff you've already learned and tested on, okay? That's why I went pretty fast with that. But now we have a remainder. So what we do is, since it's positive, we're going to put plus 3 over the divisor. The divisor was x plus 2. So this whole thing is the answer. X plus 1 plus 3 over x plus 2. This divisor should always equal this. So because I had a remainder, that means x plus 2 is not a factor and negative 2 is not a root. Okay? It's kind of similar to, let's say we were dividing 8 into 30, okay? So 8 into 30 would go 3 times. 3 times 8 is 24. Subtract, this gives me 6. That's the remainder. So you would put 6 over 8 as a remainder. Okay, so it's the same exact thing, same exact concept that you used to do in elementary school, although you haven't done it in quite some time because you all use calculators. So that's a little different with that. Okay, so now we'll do another long division. On the back we'll do some box, okay? Or maybe I'll do this one both ways for you instead. I know most of you use the box. But again, this is all review, so it doesn't really matter which method you use, okay? So if I do the box, I have an x to the third that goes in the box. When I divide, I get x squared. If I multiply, I get negative 2x squared. Then this diagonal should equal my next term. And if you notice, we are missing the x squared and we are missing an x to the first. We only have the constant. So this should equal 0x squared. So I would need to add the opposite, 2x squared. These two add to nothing. So now divide again, positive 2x, multiply down, negative 4x. Again, the next diagonal should equal that next term, which is 0x, so this is going to add the opposite. Divide in, and we're going to get a positive 4. That's going to give me a negative 8. This is where you used to stop. But this negative 8 does not match that negative 4, so we need to do a final diagonal, which means we kind of need to add a box there. So this diagonal should equal negative 4. So what would have to go here to add would be a positive 12. Because 12 minus 8, no it's not, a positive 4. Oh my goodness, sorry. This is why we check. So this and this is a negative 4. Another way to do it is negative 4 minus negative 8. This would change to plus positive, and that would give me the positive 4 there, okay? I was doing adding and getting a positive, sorry. So this is now my remainder. So my answer would be x squared plus 2x plus 4 plus, because this is a positive, 4 over the divisor, x minus 2, okay? Let's do it by long division as well. So it is an x minus 2 dividing into x cubed minus 4. So I need to put my placeholders in here in order to do this division. So x goes into this, x squared times x is x cubed. X squared times negative 2 is a negative 2x squared. Change each sign. This cancels. This gives me 2x squared. Bring down the 0x. This goes in positive 2x times. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Change signs. This cancels. 4x comes down. Bring down the minus 4. X goes into this. Plus 4 times. 4 times x is 4x. 4 times negative 2 is a negative 8. Change signs. This cancels. This gives me a positive 4. The positive 4 is our 4 remaining over x minus 2. This gave us the same exact answer. Okay? So really the only new step is that last piece. Okay? Everything else is the same. All right? So I'll do this one by the box, and then I think you should be fine. And again, if not, rewind it. Okay? Pause it, ask for help in class, and we'll go over it again tomorrow as well. So we're dividing this by this. So I'm going to go x squared here. I divide it in, I get x. Multiply down, I get 2x. This diagonal should add to 3x. That means I need another x here. So it's 3x minus 2x is x. This gives me a positive 1. Positive 1 times this is 2. But this 2 does not equal this 5. So this diagonal needs to equal 5. So 5 minus 2 is 3. So that means I need a plus 3 over x plus 2. Whatever this final number is, when this doesn't match that last constant term, you just put it over the divisor. Okay, that's the only difference. All right, so tomorrow we will go ahead and do a bunch of these. Okay, we'll do some together and some in groups so that you get some more practice. Okay, bye.